So hi everybody, I welcome you all to the day 6 of DSA placements, and I am Vaibhav Shukla, and let's go ahead and let's learn the data structures and algorithms on the day 6. So basically we've done a lot so far, and in 5 days we've learned a lot of topics. So before I proceed further to all of you, first of all I would like to welcome here, and just tell me in the live chat section whether I am visible and whether I am audible to you or not. So just confirm me this, and then we'll begin with today's session. I can see your chats. Rather, I'll keep my laptop here so that I can see your chats conveniently. You go ahead and confirm whether I'm visible and audible to you. If yes, then just type a yes, and then we'll begin. Fine. So फटाफट से एक बार yes no कर दो in the chat section if I am visible and if I am audible. Great. बहुत बढ़िया. So it's the day 6 today. Fine, we are here on day 6, and so far we have covered arrays, we have covered hashing, we have covered two pointers, we have covered stacks, we have covered linked lists, we have covered trees. Fine. So all this has been done. Good evening, good evening. Fine. So all this has been done so far, and to all of you I would tell you one very interesting thing, one dreaded topic which a lot of people fear. Graphs would be done today. Fine. Today we will cover this particular topic, graphs, and I'll go very slow. Basically I'll go ahead and I'll explain a question which would actually clear all your inhibitions about graph. Number one. Number two, graphs is usually a very challenging topic for every student. Fine. So I'll break it down in a very simpler manner. I'll just explain you one line, and with that you could easily identify graph. Fine. Number one. Hi, good evening everybody. Fine. Also, all of you can go ahead and ping me on this Instagram handle if you have any doubt. If you want to discuss anything, then @Shuklaji Speaks is my Instagram handle. You can connect with me, and there I can help you out with it. Okay. So if I go further, fine, then today let's straight away start with the very basic. And when we start with the very basic, the first thing in graphs that would we understand would be the definition of graphs. Okay. So if I start the definition of graphs, what exactly is a graph? A combination of nodes, you also call them vertex, fine, or vertices if there are many, fine. So nodes and edges. Any combination of nodes and edges is actually a graph. Now if I tell you that this is this a graph? Yes, this is a graph. Fine. Correct Nishant. A combination of nodes and edges. So yes, this is a graph. Is this a graph? Is this a graph? Yes, it is a graph. Now a lot of people would say that this particular structure seems to be a tree. Yesterday, so if we are aiming for 7-8 LPA service with company profiles like digital DSC turbo, how or what kind of questions we can expect? Lead code easy to medium questions. Fine. In 150 not out, in every topic the initial 5 to 6 questions can be done to crack that digital. Okay Anuj. Now anybody who sees this would say this is a tree, right? But I would say this is tree as well as a graph. Okay, this is tree as well as a graph. Now why am I saying it is a graph? Why am I saying it that this is a graph? A very simple reason is it satisfies this particular condition. It satisfies this particular condition. As simple as that. उससे ज़्यादा सोचना ही नहीं है. If it is a combination of nodes and edges, it is a graph. Simple. Fine. To all of you, I'll put some examples in front of you. Now tell me. The structure that I have just drawn, is it a graph? Is it a graph? Tell me. Tell me. Is it a graph? Yes. Okay. So why is it a graph? Anybody who is saying this is a graph, tell me why is it a graph? Malarapu Gayatri, correct. Nishant is also saying it is a graph. But why? Why are you saying it is a graph? Tell me the reason to it. Why I can say this is a graph? Correct. Edges and nodes. This is combination of edges and nodes, right? So it is a graph. Yes. It is absolutely a graph. Bilkul. Bilkul. Perfect. Now if I make something like this, is this a graph? Is this a graph? Tell me. In a straight line, in a skewed manner, I have joined the nodes. Is this a graph? Tell me. Yes, absolutely correct. Same definition works. Combination of nodes and edges. Anybody might tell you n number of definitions about graph. Keep your concept simple and clear. Do not worry a lot about it. Okay, don't actually bother yourself or burden yourself that this is the definition or people say this. No, you need not to worry a lot about it. Fine. So this is absolutely a graph. Now, yesterday I had promised all of you that I would go ahead and I would explain something called as DFS as well as BFS. Okay. So what are all these things? Today we'll understand it well. And I will explain them as well in a very simple manner. I will not complicate them for you. These are very, very easy concepts. But let me tell you one very important thing. Any concept, any problem related to graph would have their implementation. Okay. Whenever you are having a problem of graph and if you find it, then remember one thing, DFS or BFS is somehow going to be applied. That is a shortcut that I'm telling you. A lot of people might say, do not straight away plunge into DFS or BFS. Do straight away plunge. I'm telling you. The reason is, somewhere or the other, DFS or BFS would be solving your problem in some or the other manner. And I'll show you today. These are searching techniques. Perfect. I'll show you today. See, for example, this is a graph. Fine. And I'll make it like this. And then I'll make 4, then 5, and then 6. Okay. So when you're actually going ahead and using BFS, fine, this is BFS. Okay. Rather, for explaining BFS, I would make an example which would be easy for you to understand. Okay. Let's make it like this. It remains same. Nothing changes. Fine. Nothing changes. It remains same. Just that I've done 2 branches of 4. So BFS is a breadth first search. This is also called level order traversal. Fine. Basically, here I go level by level. So I go in this manner. Okay. The traversal is done in this manner. What basically I'm saying is that if I talk about this particular graph, this is the level 1. This is the level 2. Both are at level 2. This is the level 3. This is the level 4. Fine. Whenever I go ahead and I try implementing BFS, what would I do? 1, then 2, I would visit. Then basically at every level I'll visit. At every particular level I'll visit all the existing nodes. So basically if I go ahead at first level, 1 is only present. Then at the second level, 2 and 3 are present. Then at the third level, only 4 is present. At the fourth level, 5 and 6 are present. Okay. So BFS is always done in the order of preference wherever they are sitting. Fine. So it is about the breadth of the graph. Fine. The width of the graph. You get it? Hi Tarun. So it is about this. By every level, I'll go further and further and further, and at every level, for example, had there been 2 more vertex here, fine, say 7 and 8, then what would have been the case? The traversal would have been 1, 2, 3. Now tell me what else? Tell me what should I write here? What next? Fatavat batao. What should I write the next thing here? After 1, 2 and 3. Now I have added 7 and 8 as its nodes. Tell me. What should I add? Fatavat batao. You want to draw it with green, I'll do it, don't worry, I'll draw it with the green pen. Okay, 7 and 8. Now tell me. Okay, so somebody is saying 7, 1 2 3 के बाद 7. Okay, then 8, correct Nishant, and then 4, absolutely right. 7 8 4 is the correct order. 7 8 4 is the correct order. Fine, because they are at the same level. Fine, this is breadth first search. इतना ही होता है breadth first search. This is no rocket science. All you need to do is you create an adjacency matrix. This is called adjacency matrix, and then you create a visited list. Fine, you create a visited list. So in visited list, basically you add those numbers which have been, or those nodes which have been visited. In adjacency matrix, you actually add the addition matrix. For example, in 1 2 and 3, I go ahead, if I visit 1, I'll add 2 and 3. Then 2 and 3 are in the same level, I'll visit them. Then I'll go ahead for 2 and 3, 7 8 and 4 for the adjacent. Similarly, they will come here. Post that, for 4 5 and 6 were adjacent. First 5 would be visited, then 6 would be visited. Okay, that's how level order traversal or breadth first search works. Interesting case is of depth first search. It is quite an interesting technique. Depth first search. It is quite an interesting technique. Why am I saying so? Let's take the same example. Okay, now in this, depth first is always about, correct, backtracking based, correct, very good. It is about the depth of it, and I love this, that my students go ahead, they try their level best, they try that, they go back, they study things. I'm really appreciating the fact that you guys are studying yourself. Very good, Gayatri, well done, you're on the right track. Fine. Now backtracking based approach is there. Every time you go to the depth of the graph, when you have a graph in front of you, you go to the depth of it, you try exploring the depth of the graph. Level by level isn't visited, it is going in the deep path, or I would say you would go ahead and find the depth of the last node. Till the last node you will try and reach. So I'll show you what happens in depth first search. Okay, so let's say you started from 1. Okay, let's say you started from 1. So the first thing that you can go is, you have 2 depths here, either 2 or 3, so you go towards 2. Okay, then in 2 also you have 2 different things. Find 2 different depths, so I'll go ahead to 7. Ideally I'll go to 7. Now here, once I have visited 1, I have visited 2, I have visited 7, then I do not have any depth further, right? So I'll backtrack it, I'll go back. Fine, I'll come to this level again. Now I have another depth here, so I'll explore it, I'll visit it. So basically 1 2 7, then 8, and then I'll go ahead, because there is no further depth, I'll go ahead, I'll backtrack from here, I'll backtrack from here. From 1 again, I'll go and explore this 3. Fine, so I'll add this 3 here, it would be visited. Post this 3 is visited, what is the further depth? 4 is the further depth, so I'll visit the 4. Then after 4, what is the further depth? 5 is the further depth. Fine, correct Nishant, very good. 5 is the further depth. Now you do not have any depth further. Fine, you've visited this, you've visited this, you come back, and then you go to this particular place. Fine, you go to 6. Fine, you go to 6, you visit 6. Once you visit it, you actually have 6, and then there's nothing left, everything is visited. This is depth first search. You got it? This is depth first search. You try and explore depths of it. Correct? Is it clear to everybody? Now in this also you have adjacency matrix. Fine, and then you have visited list. Now what if I tell you begin with 3? What if I tell you initial is 3? So I've visited 3 here. What would happen? How would DFS work? Let's see that. Okay, so let's see how would actually DFS work in that case. Okay, So I'll go ahead. Perfect. Now what I'll do is, I have told you that this is this time the initial visited thing. So 3 is the initial visited node. What will I do now? I'll try and explore the depth. So the very obvious depth is 4, right? So if in adjacency matrix 4 would come, so 4 would be visited, 4 is visited, now 4 comes here. What are the next adjacent? 5 and 6. So first of all 5 would be visited, 5 is visited, then I do not have any further depth. I go back here, I go to 6 now because that is the only thing left. I visit the 6 as well and keep it in visited. Now this whole portion is visited. Okay, so I have nothing to go further. I'll go back here, I'll backtrack again. From 3 I'll see what is the depth. Again 1 is the depth. So from 3, when I had put 3 here, I would have also put 1 here in the adjacency matrix. Now I would visit 1 because I had chosen the path of 4, I had gone to 5 and 6. So now I'm visiting 1. When I visit 1, I would have 2 in my adjacency matrix because this is the further depth. I'll visit the 2. Once I visit 2, I'll have 7 and 8 in my adjacency matrix. I visited 2. So first of all, I'll go to 7. I'll visit 7. Then I'll go to 8. I'll visit 8. This is as simple as that. This is the way you can go ahead in DFS. Fine. TCS and Microsoft should not be in the same line if we are taking interviews into consideration. Definitely they are not in same line. Girishankar, who is saying that they are in same line? However, if you're reading this particular title of this YouTube live, why I have put it is, this live is useful for service based as well as for product based companies, because I give you the complete concept, I let you solve some queries, some questions, some good questions which are usually of medium level, and then I provide you the homework, and if you do that, you'll be able to enter Microsoft as well. Fine. Is this the same Prepinsta site which has aptitude questions? Yes, Girishankar, it is the same website. Fine. It has aptitude, coding, and various other plethora of things which can help you out. Now this is depth first search. You've understood the concepts. Fine. Oh, great Girishankar. I would request you, please connect with our team, and team, please connect with Girishankar, because if he has cleared TCS, we would love to hear your story, Girishankar. Fine. Now let's go ahead, and that's why Prepinsta is doing things with flying colors, because people here like this are our motivation factor. Great, Girishankar, congratulations. Now I'll go ahead, let's straight away dive into an actual question like we always do. Fine, so let's go ahead here and I'll open the not out 150 list and let's go. Let's study over this. So I'll slide down to graphs, and in graphs let's do the number of islands question. Fine. So what does this question say? I'll straight away explain you in the slideshow only. Okay. So what does this question say? True, best site for coding and aptitude from interview perspective. Thank you, Girishankar. Thank you. So that's pretty much the testimonial, guys. That would help you out. Now, what is the number of islands problem? So basically, what you are saying is you have a 2D matrix. Fine. You have a 2D matrix. Say like this. Fine. Say like this. You have a 2D matrix and you have 0, 0, 0, 0, 1, 1, 1, 1. Then you have 0, 0, 0, 0, 1, 0, 1, 0. Okay. You have such matrix. In this, 0 means water, 1 means land. Whenever a sequence of land is surrounded by zeros, it is called an island. Fine. Basically, what is an island? Island is a land surrounded by water from all sides. Fine. So if you see this particular group and all the land together, if it can be linked in these 8 directions, fine, then it is a piece of land which is together. Okay, so if you see here, this is a piece of land together because diagonally also they are connected. Fine. And horizontally and vertically they are connected. So this is a complete piece of land. Fine, I would take some other ink, and this is a complete piece of land if you see. So this is one island, if you can see. This is another island because it is covered with water on all sides. This is also one island. Okay, these are the islands. So basically what you have to do is you have to count the number of islands. As simple as that. All you need to do is you have to count the number of islands. How would you do that? Let's think it for a while. Let's think how would we do that. So the very simple thing that we can do is we first of all create another matrix. Okay, another duplicate matrix of this, absolutely same. Okay, just an absolute copy of it but in a different manner. Not a good and symmetric matrix, so I'll make it in a symmetric order. Still better than the earlier one. So what I'm saying is I number it basically 0 1 2 3 0 1 2 3. Okay, so if you see carefully, what's happening here is in this basically here also I'll put it like this 2 3. So in 0 2 and 0 3, if you carefully see, if I go ahead and I visit 0 2, it can be visited. Fine, I'll marking it as visited. Okay, now from this one, if I take it as a starting node and if I run DFS, can I go to the adjacent places? I can go here. Fine, I can visit this up. I can go here, I can visit this up. So this would be visited, this would be visited. If I go further, fine, if I go further from these, any of these two, I can reach here, I can visit this as well. Correct? So this would be visited. Once I reach here, is there any further one where I can go in any direction? No, it's not. Correct? Nowhere it is to be found. If nowhere it is to be found, what will you do? The very simple thing is, here you stop, you backtrack, you stop. Okay, so this is one particular place where you found a island, where you on all sides you found that there is water, because here also no depth is left for this node, here also no depth is left because this is out of the range, so invalid, and here also there is no depth left. Then you move further, you scan this particular row, you scanned this row, you first of all you scanned this, then you will come to this, this is already traversed. Now you will go scan this, it will say I am traversed, this also will say I am traversed. Done. Here you come, no one found. You come further here, you found out this has not been traversed, right? So when you run DFS on it, this would be traversed, you have no other one connected to it, so depth would stop here. Correct? Similarly, when you run DFS on it, the depth would stop here, both of them are now visited. So basically what I am saying is these two will also be visited, right? These two will also be visited. Now out of these, how will you identify? You just did the traversals, you just visited all of them, but how would you identify that this is the number of islands here? So how would I identify? Every time I'll keep a counter or an output variable. Fine, I'll keep an output variable. Every time I encounter a node which is unvisited, I would increment this output. For example, when I started, how would I know that I should start DFS on this node? So this output variable will tell me, I'll tell you. So basically I'm saying, for example, here I knew this is a starting node for a DFS because I can increment output on this with +1. The reason is I'll make 1, I'll increment it with 1. So why I can do this up? Why can I do this up? The reason is this node was initially not visited at all. Fine, initially it was 0, initially output was 0, say, fine, and here I visited this for first time and I ran DFS. In that process I visited this node as well, I covered this node as well, I covered this node as well, but the only unvisited node that I initially encountered was the 0 to 1. So I would add 1 to it, I would make it 1. Now when I go further and when I scan this in the second time, this would be already visited. Similarly, when I check this, this would also be visited. When I check this node, this would also be visited because of the DFS that occurred when I visited this for the first time. Okay, Then again, if I go further and I visit this would be visited for the first time, so I would again implement 1 plus 1, which would become 2. When I again go further, this would also be unvisited, and this would become 2 plus 1 equals to 3. So 3 would be the final output, and 3 is the number of islands that you have. Is it clear? Is the question clear to everybody? You know the logic now. All we need to do is code. Is the question clear? Is the logic clear to everybody? Fatafat ek baar batao, then we'll move to the coding portion. Because if you can do this question, you can do any question. I'm not kidding. If you can understand this question, you'll go further, you'll understand any question. Good. Gayatri, you understood. Everybody else understood. Very easy question, but sometimes we feel that graphs is a difficult portion. But as Feynman told it once, if you're studying the science and you're finding it boring, you're studying it from the wrong teacher. Same goes with DSA. So that's great to hear that it is clear to you. Now I'll go further. I'll explain the code. Okay. Let's go to the code. So I'll go to the coding portion and I'll explain you this code straight away. Fine. So if I go in Python language, what is happening here basically? Because here a few things would have to be understood carefully. Now if you see, I have defined, let's go ahead and let's take a screenshot of it so I can actually explain you better. Fine. So shift window and S, I guess it's working now. Yes, it is. So I'll take a complete screenshot of it, and later on I'll show you the portion that is actually being cut. Okay, later on I'll show you this particular portion. I'll show you later on. First of all, let's go ahead and let's paste it here. Let's understand it step by step now. Okay, so I hope it is visible to everybody, and now I'll explain this up. So what's happening here is, there is some very simple logic that is going on here and that is happening, so I'll explain you that. So what's happening here is, I have defined a num islands function where you're actually having a grid, and this grid is basically a two-dimensional list that I showed you, basically this, fine, where you're storing all those numbers, and this function would have a return type of integer. Integer would be returned. Now I have initially set output as 0. This was the output variable. This is now 0. Fine. I have given directions 0, 1, 0, minus 1, 1, 0, and minus 1, 0. Now what is this? 0, 1. 0, 1 is basically, whenever I give you this direction 0 and 1, what is happening? The initial row is the same. I am adding 1 to the column, which means the right direction of it. If this is 0, 0, if this position, let's say this is a matrix that you have, if this is, I'll rather make it like this so that you understand it better. So if this cell, if this particular cell is 0, 0, then this is 0, 1, right? This is 0, minus 1. Fine. So the left direction is 0, minus 1. The right direction is 0, 1. Okay. Now when you go ahead and you find 1, 0, what is 1, 0? Basically 1, 0 is this. When I go further, this is 1, 0, because I'm adding 1 to the row, so increment the row by 1, the column should not change. If I go minus 1, 0, so it would be above it. Okay, so these basically represent these 4 directions. Why are we using just these 4 directions? Why are we using them? The reason is, it is a 2D matrix. Only these 4 directions can fulfill our purpose. Okay, so these are basically directions which are written here. Okay, I have defined directions. Now I have a visited set, basically where I can store the traversed values. So I'll have visited set where I would store traversed vertex. Fine. Now I define DFS where current x and current y would be passed. Fine. What you would do is, wherever you actually visit, you would add the current x and current y, and then for direction of x and direction of y and directions, what you would do is, you would establish the next x and next y based on the directions that you find here. Fine. Whatever for every direction, basically you will check now. How does DFS work? DFS has to check in every direction for the depth. So for every direction, basically I'm running this loop, and for every direction it would one by one add, and it would run accordingly, and the next vertex would be decided. For every next vertex, what would I, or the next, basically this in grid, how would I move to the next? By adding the directions only, no? Now how do I actually check that this particular next node is something that I should go ahead and I should apply DFS on? How do I get it? So the very simple reason is, if next of x is in range of length of grid and next of y is in range of length of grid, basically if next, for example, if I go for this, the next of x would be there, but the next of y, because next of x is 0, but the next of y is not present, right? Similarly, if I go here and I go to the next row, next of x is not available, correct? It is not available. So it should be in the limits of the grid, basically it should be under the length of grid and the grid of next of x and next of y. So basically whatever particular position you're trying to scan should be 1, and the next of x and next of y not in. Now this is something important which I'll show you here. Next of x and next of y is not in visited. If it is not in visited, run DFS over it. Basically run this DFS again over it and add it to visited. You got it? Same thing that I just explained you. Basically what's happening here is, I'll explain you because that would give you a better clarity. What I'm saying is, I'll again draw that for you. See, if this is the matrix, fine, this is the matrix, and if in this case I'm saying 0 0 1 1 0 0 1 1 0 0 0 0 1 0 1 0, and in this case I'm saying if I visited this for the first time and I did DFS, so what I'll do is visited, I'll put in visited, and this is say 0 1 2 3, again 0 1 2 3, so I'll add 0 and 2 in this visited set. I'll add 0 and 2, this vertex is added here. Now when I apply and I go further, this is in range, this is 1, so basically this is an island, this is a piece of land. I need to check whether it is there or not. If it is there, I'll run DFS over it. So basically if DFS was running like this, 0 and 2 was there, and then DFS runs over it, so 0 and 3 would come here, fine, 0 and 3 would come here, and then DFS would go further, the DFS would go further, next of x and next of y, it would be called for 0 of 3. Now if I run for DFS of x, so next of x is basically here getting out of bounds, correct? Then the backtracking would happen, then again it would run and it would come here, then the same thing would work for, first of all here only DFS would work, it would come here, correct? It would visit the 1 comma 2, then it would go ahead, it would visit this 1 comma 3. Once they are all visited, now what would happen? This has all been visited due to DFS, we just ran it. Once it has been run, and when I try scanning this particular row, even before scanning this particular row, when I try to scan this particular node 0 and 3, now this condition that we had not in visited, this would automatically be not fulfilled. This would not be fulfilled. The reason is, it is already present in visited. This is already present in visited, so it would not visit it again. It would not go further. The code block here would not execute this DFS because it is already present in visited. So this would not execute, okay? Then if I go and check for this, again will not execute, already visited. For this, already visited. When you come back again on this particular portion, it would go ahead. It would visit 3 comma 0, fine, 3 comma 0 would be added here. Again it would visit this particular 3 comma 2 vertex, this would be visited. Now every time you were actually doing this for I in range, this would actually work for every DFS. For I in range of length of grid, for every basically this row you will iterate, and for every column I am putting another particular loop here, fine. For j in range length of grid 0, if grid of I or j is equal to 1 and I and j is not in visited, so basically whenever you find any new vertex which is not visited, so this was not visited, this was not visited, this was not visited, every time you were finding it, basically what were you doing was you were adding 1 to the output that we were doing earlier, fine. So you were adding 1 to the output and then you were going ahead with DFS for the further particular node, okay, which was nothing but this being called, this DFS being called, okay, this function being called, that's it. So every time you were adding 1 whenever you were encountering a new node. So when you were encountering a new node, let's check. So basically you encountered a new node here, then you encountered a new node here, and then you encountered a new node here. Rest of these 3 were part of DFS of 0, 2, isn't it? This was a part of DFS of 0, 2, because this DFS of 0, 2 led to DFS of 0, 3, fine, which in turn led to further DFS. This DFS only continued to DFS of 1, 2 to DFS of 1, 3. So this was part of whole one DFS. This was complete part of one DFS, but the new node was encountered here, here, and here. So it is 3 different islands. That's how you basically return the output here. Okay, because at 3 times output would be initially 0, then after visiting this particular node it would become 1, so I would make it 1. Then after this visiting it would become 2, I would make it 2, and then after visiting this it would become 3. So totally this will be the final result. This would be the final output which would be returned. Is the question clear to everybody? Is the question clear to everybody? Tell me. Isn't it an easy peasy question? फटाफट बताओ. Is the question clear? If there is any doubt, go ahead, ask it out. If there is no doubt, then I'll proceed further with the homework that I have to give you. But this is by far the question that can be easily done. Fine. Same thing if I explain in Java and C++, same thing is happening actually. In Java also, if you see, you actually pair it up first and second, and great Junu, if it is clear, great. Same thing is happening here. Again, you pair it up, you use DFS in this particular function. Here BFS has been used. Breadth first search can also be used. Level order traversal can be done. Fine. So very easy thing, not a rocket science to be worked out here. Fine, an easy peasy job. And here if I tell you exactly the BFS traversal is happening, similarly I go ahead, I check at every level, and then I group the particular islands. Same here is happening if you haven't visited, and if it is a new thing, you basically increase the particular node size. You go ahead, you keep on doing BFS. This is the breadth first search code. Then you go ahead further, and then you create a count. This counter variable is basically counting your nodes, and every time you have a cell which contains 1 and has not been visited, you increment count. Simple. Okay, same goes in C++. Absolutely same kind of grid being created, same directions being defined, same num islands being used. Fine. Every time island count is increasing when you visit a particular row and column which has not been visited earlier. Simple, very simple. Fine. Now to all of you, I'll give you some homework. In graphs, I'll give you only 3 questions as homework, which is max area of island. Using the similar kind of technique, this question can be solved. This would also use DFS and BFS. You can use this out. Then apart from this, you can use clone graph, you can use walls and gates, and post walls and gates you can move to this Pacific Atlantic water flow. Do not go for this rotting oranges. Fine. This is a very old problem. Now it is not being asked in interviews. So you do this homework, and that would help you out pretty much in graphs. Tomorrow we'll try some, in the next live, not tomorrow, in the next live we'll go ahead, we'll try something for the DP questions, the dynamic programming questions. Till then, stay tuned, keep working hard, and only one thing I'll say to you, go ahead, spread this knowledge as far as you can. Keep doing good for others without any expectations. Fine. Good will always come back to you. Next session would be the last session for this, so do not miss out on that. That would help you out a lot. Along with that, if you want to enter into the deep dive of data structures, if you want to understand them, then you can go ahead on prepinstaprime.com, and here you can learn from these DSA courses, which are full length, in-depth, advanced courses for DSA in your favorite language. All you need to do is go to Get Prime, and then select your subscription accordingly. For example, if I select for 48 months and I put the coupon code Shukla10 here, fine, so that would immediately provide you some discount over the final pricing. Fine. So it would somehow provide you the discount over it. So I'll get this coupon code done by the end of this, and you can go ahead and help yourself out with this. So that's pretty much for today's session, Have a wonderful day ahead, guys, and keep spreading the goodness. Keep doing good for others, as I said, without any expectation. Good will always come back to you. Have a wonderful day ahead. Bye bye.